Okay. So basically, this paper, you know that this paper will be taught in two parts. So algorithm, flowchart, and few things will be discussed in other classroom. So it will be discussed by Debraj sir, and I will discuss the programming part. So though these two things are very correlated, but we don't have option at this moment. So that's why I will try to touch something from that section also. And when he will teach you, then at that time he will discuss something whenever it is needed. Uh, so two things cannot be done parallelly, but still we don't have provision, so we have to execute it in this way. Okay, so if you have any doubt at any moment, please stop me and we will try to discuss it there. Okay. Uh, okay, in presentation mode, it is not coming. Just wait for a minute. I'll try to hide it. Hello.
Yes, sir.
Okay. Uh, I have to share it in different way. Before starting this coding section, I will discuss something, though it will be discussed later on again, because at this moment, everything cannot be discussed in this part. But for better understanding, as you are already familiar with the programming language, let us start with this discussion. Okay, so uh, all of you are familiar with Python. Sometimes you are familiar with some other programming language. Let us try to understand that how C program executes. Okay, so how it will execute? So basically, we will write one program like test.c. Okay, so this program will be compiled, and finally, in Linux environment, it will generate a.out file. And in Windows, if you compile it on Windows environment, then the executable file name will be test.exe. Okay, so this file can be executed on your system. So basically, so why we are writing this C program? We have discussed in the previous class that why we are preferring high level programming language. Okay, instead of directly writing it in machine level programming language or in assembly level code. So we are considering high level programming language because the development time can be reduced efficiently. Okay, so on our system, if we run a.out or test.exe file, this program will be executed. But this on test.c is basically, we say that this one is a program. So you have written this program. Similarly, test.exe or a.out, they are also program. Okay, nothing else. So these are programs. So this program test.c is written in high level programming language, as we know that C is high level programming language. So it's high level programming language. And this, if we consider this exe file, it's a machine level code. Okay, so it's machine level code. But we can write some this type of program in some other language also. Directly we can write it in assembly level code also. Okay, now we have to understand that what happens here. So I will write one sample program here, just like hash include. So content of this test.c is hash include stdio dot h. So I'm writing this program hash include stdio dot h, and uh, I have a main function. So int main, and here I have just written only one statement to check whether this program is running or not. So say this one is hello world. This is our program, hello world, and finally this function will return 0. This value is 0, it's not O. Okay. So if I write this program, then what happens? So this one is written in C programming language. So this is the content of test.c program. Now this program during compilation, it will go through some phases. So first, an intermediate code will be generated during compilation. From this intermediate code, system will generate assembly level code, and from this assembly level code, it will generate object code, and finally an executable file will be generated. On your system, you will not be able to see these intermediate codes, but internally these intermediate codes are being generated, and finally this file a.out or test.exe file, this one will be kept in your system, which you can execute. Okay. Now you know that C is, you have heard that C is machine dependent code. It's not independent. Okay. So if we compile this program on Linux environment, the executable file is a.out. Whereas if we compile this program on Windows environment, then test.exe will be generated. Okay. Now, if I want to run, so this one will be generated in Linux environment, just writing it here, and this one is for Windows environment. Okay. Now, after compilation, this a.out or test.exe, these executable files can be run on a system. So if I want to run this a.out file on Windows platform, it will not run. Similarly, if I want to run test.exe in Linux environment, it will not run. The reason is we have discussed earlier, but we have not discussed with an example. So basically, these executable files contain some instructions which are dependent on your system architecture. So if you are using Windows 32-bit or 64-bit, it is dependent on that. If you are using Linux 32 or 64-bit, it is dependent on that. So that's why once we are compiling the code which is being generated to be executed on a platform, it should generate on similar type of platform. So if you write a program, you have just, I'm assuming that you have written one very simple but interesting program. You have written calculator.c. So you will not share this source code with your friend, but instead of sharing this program, you will prefer to compile it. So after compilation, it will generate calculator.exe. Okay. So this calculator.exe, you can share it with your friend. Okay. So if you share this program, so basically we are not always, we are not preferring to share our source code. Instead of sharing the source code, we are sharing the executable file. So after compilation, the executable file is being generated, which is being shared among the friends. The same thing is happening like when you are downloading Microsoft Office or any other software. Do you get the source code? In most of the cases, we are not getting the source code. Even in Windows environment, the source code is available rarely, but in Linux environment, sometimes some source codes are available. Okay, but we are not sharing the source code generally. So instead of sharing the source code or .c file, you can share the executable file. So you can compile your code and you can share it with your friends. Now, is there any problem here? So basically, if I generate this executable file and if I want to share it with our friends, then we will share this .exe file. Now, if I compile it on 32-bit architecture on Windows environment, and if my friend is using Windows 64-bit architecture, this program may not run. And obviously, if you compile it on Windows environment and if you want to execute it in Linux environment, it will never run. Okay? And vice versa. So the problem is, so machine level instructions are basically dependent on the system architecture and hardware. Okay, so if we use any system architecture or hardware, then based on that, this exe file will be generated. So it will contain that kind of instructions, so which may not run on other platforms. That's why C programming language is known as platform dependent. It's not platform independent. Okay, in Python, when you have written some code, if you write it on Windows environment or on Linux environment, do you generate any executable file or directly you run this program? There is a provision to generate an executable file, but generally we run this program on our system directly from the source code. We are not talking about this direct execution. Okay, so we are compiling the code, we are generating the executable file which will run on a system. Okay, now, so this is the steps. These are the steps which are being used during executable file generation. I will show you by saving some intermediate files. So directly when you are compiling this program test.c, when this executable file is being generated, at that time, these are the intermediate files which are being generated, but it is not being saved on your machine permanently. But if you want to force your system during compilation to save the intermediate files, then it will be saved. Okay, so later on I will show you when we will discuss preprocessor. This is one chapter of this paper. So when we will discuss preprocessor, during that time we will show you that how these phases are being performed. Okay, okay. Any doubt in this section at this moment in this discussion?
No, sir.
Okay. So now I will share my screen and let us try to write one program. Is it visible to everyone or I have to increase the font size?
No, sir, it's visible.
Okay. So here, uh, let's try with the very basic program. Okay. In C programming language, uh, this one is a little bit different with Python. At this moment, we will not be able to discuss all the points that what are the differences because we have no idea about this memory allocation in C programming language and many other things. So that's why it's not possible to discuss at this moment, but later on you will understand that what is the basic difference between C programming language and Python. Okay, now let us try to understand that how this program works. So what happens here? So basically in C programming language, we have one function, main. So program will start execution from this main. So whenever we are writing some instructions, like in this program, I have written one printf statement. So this printf statement will print hello world. Okay. So this line will be printed on screen. And finally, this function will return a value. This function will return a value to the operating system. And this is the simple program. So if I run this program, so you can see that this is the output. So hello world is being printed here. Okay. So the message I have written in printf statement, this one is being printed here. So now we'll try to understand, as you are already familiar with Python, that's why we don't need to discuss it in detail. So main is a
Sir, not
function.
all, not all. I don't know anything about Python, sir.
But it was whether it was mandatory? in your first semester?
No, sir.
It was not mandatory. Okay, okay, fine. Okay, then I will not compare it with any other programming language anymore. Okay, thanks for the information.
So Python was not in our semester actually. Python, we did Python for the NPTEL. It was for MOOCs.
Okay. Yeah. So whether everyone has completed the course or some of you?
No, sir. No, sir.
So it's not completed yet. It's still going on. But sir, not everyone has done it.
Okay, okay. Fine.
We
Thanks for the
wanted
information. Okay. Yeah. Okay, then we'll start from the very basic. So in a programming language like C, the program will start execution from main. We will discuss function in detail later, but at this moment, remember one thing, that main is a function. Okay. So if I write something in main, then from here the program will be started. Okay. So which one is the, so this is the syntax. So int main, so int is basically a value which will be returned by this program. Okay. So when we are running this program, a process is running on your machine. So basically this process will start from main function. So at this moment, you should remember that every program in C programming language, every program will have a main function and program will start execution from main. Okay. Now we want to test how to interact with a screen. So I want to print something. Okay. So if I want to print something on my screen to test whether this program is running properly or not. Okay. So here I'm using printf. So printf is again a function. Okay. So I'll just explain it here. I should not. Okay, just wait for a minute. Okay, so here, what we have written here in this program. Okay, in this program, this is the content. Hash include stdio.h. Then we have int main, then printf, and a return statement. So what does it mean? So here in this program, main is a function. Okay, so here this main is a function. It's a name of the function. Okay, remember these points. So it's a name of a function, and always this main function program will start program. If you write any program, then program will start from this main function. So it will start from main function. Okay, and what is printf here? Printf is again in our example, this printf is a function. Printf is again a function. Okay, what is the purpose of printf? So its purpose is basically to print something on screen. It will print something. So something means whatever you will write in printf, that will be printed on screen. Okay, now this main function, so in this program, this is the body of the main function. Okay, so this is the body of the main function. So this is the definition. We generally will talk this one as definition of the main function. Okay, so this is the definition of the main function. We are defining this function. So the logic of this function is being written by us. It's as simple as that. We are writing the logic of this function. So at this moment, we have only instructed the system to print something on screen. If we want to calculate something, so we will write that logic. If you want to design a calculator, then we'll write that logic. Okay. So at this moment, just we are instructing the system to print something on console. That's why printf function is being used here. Okay. So here printf is a function and its purpose is to print something on screen. Okay, nothing else. So this is a function. Now try to understand that when we are writing this printf, in this printf function, we are sending some data as parameter. We are passing some value in this printf function. So how it will be passed? So as it's a function, you have to start with first bracket and this is the closing of the first brace. Okay, so we have to write something. This one is a string. So in C programming language, we represent a string within double quote. So this string is being sent to this printf statement, a printf function. Okay, so it will be printed. So apart from this, so printf is again a function, main is again a function. Okay, so if printf both are function here, in this example, both are function. But what is the difference? This main function is defined by us. It is defined. This function is being defined by us. Okay, us means we are the developer. So we are during development, we are thinking of the logic of this function and we are implementing it. So we are writing the code. So we are defining this function. So what kind of task will be performed by this main function that is being defined by us? Okay, but in case of printf, we are saying that printf function will print something on screen. So how system will understand that printf function will be used to print something on screen? So basically, this printf function, it is predefined. Okay, so predefined means this function is already defined. Okay, so where it is defined, at this moment, I will not discuss in detail, but just remember that printf function is defined somewhere and how to interact with this printf function. So if we want to interact with this printf function, then we have to include stdio.h header file. Okay, it's a header file. That's why its extension is .h. So in stdio.h header file, this function is declared, but it's not defined there. It's defined in somewhere else. I will show you later. Just remember that printf function is declared in stdio.h, but it's defined somewhere else. It will be discussed when I will discuss function in detail. Okay, at the very beginning, we can't discuss in that much of detail. Okay, so we have to include stdio.h header file in this program so that it can understand that when it will call this printf function, it has to link with the system to get the definition of this printf function. And the logic of this printf function is already written and its purpose is to print something on console. Okay, so on your terminal or console or command prompt, the data will be printed. Okay, so that's why when we are running this program, then when we are running this program, it is already running. So if we run this program, then it will print this on screen. Okay, so this is the way how it works. Okay, now just giving you some more example to be familiar with this platform. So if I want to calculate something, like I want to add two numbers. Okay, So if I want to add two numbers, what we have to do? Say we are going to add two integer values. Okay. So we are declaring integer x and integer y. So I will declare in C programming language, I will prefer this syntax. So we are declaring two variables. So these are known as variables, x and y. Here, x and y are variables. Why they are variables? The reason is we can assign some value here. So if at this moment, if I say that x equals to 14 and y equals to, say, it's 6. Okay. So here we are declaring two variables, x equals to, and we are assigning 14 and y equals to 6. Now I want to store result of summation. So I want to add these two numbers. So I will declare another variable sum, and sum will be assigned by x plus y, nothing else. Okay. So x and y will be added and this value will be assigned in sum. Okay. Now, so if I run this program, then the output will remain same, hello world. So I want to print this value on screen. Okay, print this result. So if I want to print this result on screen, how I will print it? So instead of hello world, now I want to print this result. So I will say that I will print result. So I will use percentile %d, then the sum. Okay. I will discuss the syntaxes in detail one by one. Probably it will not be able to discuss everything today, but every syntaxes will be discussed later on. So if we use %printed percentile %d sum, then it will print the result. You can see that the value of x is 14, y equals to 6, so sum is 20. Okay. Uh, can you hear me?
Yes, sir.
Yes, sir.
Yes, sir. Okay. So in this way, it is being calculated. Now we have to understand that what is variable and why it's used. So by its name, you can understand it's a variable. So just 1 minute. My God. Okay. Just okay. Let us discuss again. So what is variable? So variable is basically memory location. Okay. So if we talk about variable here, so variable is basically a memory location. So let us try to understand here. So what is and how it will work. So it's a memory location. So when we are declaring a variable like int x, every line should terminate with semicolon so that the system during compilation, the compiler can understand that this is the end of the statement. Okay. In C program, you can notice that in every line we have used semicolon. There are some lines where we have not used it, but at the end of every instruction we have used a semicolon. Okay. So that indicates that this is the end of the line. Okay. So in this way, if we want to declare a variable, so variable is basically a memory location. So in our system, a memory location will be there. So memory location doesn't have any name. Okay. So if I want to store some data, then the data will be stored in system memory. So here we are talking about main memory. So this main memory means, so whenever we say that it's a memory, it's basically main memory. Okay. So main memory means it's RAM. okay, not hard disk. Hard disk is secondary storage. So when we are loading some data during program execution, so every time we are talking about main memory. That means in our system, it's RAM. Okay, so data is being loaded in RAM. But in memory, we have some addresses. Okay, so when we are declaring a variable x in high level programming language, the advantage is if we instead of using C programming language, if I use some low level programming language or machine level language, then we have to remember the address of this memory, the address of the memory. So at this moment, if we say that the address of this memory is 2048, this is the address, and we want to store. So in 2048, we have one data like 14 and 6 is stored in another address. So say this one is 2052. In this address, this data is stored. And finally, after calculating the sum, the result is being stored in 20, say it's a 2060. At this address, at this location, the result will be stored. So 20 is being stored here. Okay. So, recall the previous class. So when we have discussed that as a human being, it's very difficult to remember the numbers. Instead of remembering the numbers, it's easier to know them or recall them by their name. So instead of remembering huge number of addresses, if I say that if I get this provision that we can call it by X, we can call it by Y, and we can call it by sum, then it will be easier to manage. It will be easy as a developer, it will be easier to remember. So this is the purpose. That's why in a high level programming language, we have the provision to access a memory location by its name, not by address. So these are known as, so X is basically an alias. Okay, X is an alias, Y is an alias, and sum is also an alias. So instead of remembering the addresses, now we can use a name for accessing the memory location. So we don't need to remember 2048, 2052 like this. Now we can directly, we can access that memory location by calling X. Okay. So when we are declaring a memory, a variable, a memory location is being allocated. So if in this program, in our previous program, when we are declaring X, Y, and sum, basically 3 different memory locations are being allocated. Okay. Now after that, we have assigned 14 to X. So when we are writing 14 X equals to 14, at that time 14 is being written in this location. But previously it was some garbage value. We'll talk about it later. So previously it was some garbage value. Now when we are assigning X equals to 14, so when we are writing X equals to 14, then this value is being assigned here. So when we are writing Y equals to 6, then 6 is being written in this memory location. Okay. And after calculating this sum, so when we have written sum equals to X plus Y, so at that time, the result has been calculated and that result 14 plus 6, 20 has been written in that memory location, which is accessible in future by this name sum. Okay. So this is the purpose. So this is the purpose of variable. Now we have to understand that in C programming language, we have different types of variables. In here, as we are calculating something for integer data, so we are storing integer value for X, we are storing integer value for Y. So result will be obviously integer value. So if we add one integer with another integer, the result will be integer value. So that's why all the variables are declared as integer. But this int in C programming language, it represents integer, but we have to work with some other types of data also. Okay, like we have to understand the data types in a programming language. So what are the data types we have? So we have basically we have different types of uh, data in C programming language. 7 primitive data types are there. So here we have integer type, floating point type, and different types of integer numbers are there. We will come to that later on. So here we are talking about basic types. So one is integer type and another one is floating point type. Okay. So in this example, we have used integer. Okay. So I'm coming back to this screen. How much time we have? Hello.
So according to your routine, you have
15 minutes, sir.
13 minutes.
Okay.
Exactly.
Okay. According to routine, it's 13 minutes. Okay. Fine. So I will come to this discussion later. So let us try to understand. So if we use different variables, so variables are being used to store some data on which we can perform some calculation, and after calculating it, we can print it using printf statement. Now, if I want to store some fractional number, like I want to add 3.5 with 7.9, these are not integer values. So we have some other data types. These are basically floating point numbers. So these floating point numbers can be kept in some other data type. So at that time, instead of using int, I will use float. Okay. So you have to remember that what kind of data are being processed in your program. So if you want to work with integer data, you can declare a variable as integer. If you want to declare work with a floating point number, you can declare a variable as float. Okay. So you have to understand different types of data types available in C programming language. So we have 7 primitive data types. We can use, sometimes we can use some combination of them. So those things will be discussed again in future classes. Okay. Now, why these data types are needed? Like, these data types are very important. We are not thinking of only integer and floating point number because the data which will be stored in memory, it requires some size. Like um, on your reading room, in your reading room, on your table, if you want to keep your pen, do you keep it in shelf? Or if you want to put your pen, if you want to keep it somewhere, and similarly, you want to keep your exercise books and some textbooks in some location. So you will prefer to put your reading book or textbook in shelf, or prefer to put your pen in pen stand. So size of the containers are different. Okay. So size of a shelf and size of a pen stand, these things are different. I will not try to put my pen in shelf and keep my textbook on pen stand. Okay. So you have to think whenever you are working with any data, always you have to try to reduce your memory allocation. Okay. This will be done from the first day. So we have to decide that if I want to work with this type of data, what kind of data type shall I choose? Okay. So I will decide that whether it will be integer, whether it will be floating point number, whether it will be short. So I will decide based on my requirement. Okay. So this is the purpose. So this one integer will take on your system. Nowadays you are using 64-bit architecture. So in your system, integer data type means it will take 4-byte memory. Okay. Short can be used for integer data type again. but it will take 2 bytes memory. Okay, so on your system, when you are going to work with some data, you have to decide whether you will use short or int. Both are being used for integer data type, but you have to decide whether it will be short or int. Is it confusing?
No, got it.
Okay, just if I want to store age of a person. So age of a person means what will be the size of that value? What can be the maximum value? One person says can be 100 years, 110 years, not more than that. Okay, so in that case, shall I afford integer? It will take 4 bytes, but using only short, I can store that value. So if I want to store age of some animal, then I will use short instead of integer because I can save 2 bytes of memory. So when we are working with different types of data, we have to thought of that what kind of container is required. If I want to put, if I want to keep water, I will prefer glass. Okay. So, but will you keep or pour water on a plate? So containers are used for different purpose. Similarly, the data types. We have different data types in a programming language, but we have to choose an appropriate data type based on our requirement. So what kind of data I want to store, based on that, I have to decide that what kind of data type shall I use in my program. Okay. Now, in this program, I will conclude today's class with one more line here. And this syntaxes will be discussed later. I will come to this discussion later. So in previous case, I have used hello world in double quote, but now I am using percentile D and sum. Just at this moment, remember that if I use this percentile D is being used for integer values. So this percentile D is being replaced by the sum. Okay, just to test with, I can write the result is this. Okay, the result is this, or I am using this, the result is this. Sorry. The result is this. Now if I run this program, you can see the output. What is the value? I have written the result is, then space, after that percentile D is there. So percentile D is being replaced by sum. So percentile D is being replaced by 20. And finally, we have this symbol. So that is being printed on console here. Okay. Now if I write, so in this way, printf will work. So there are different syntaxes. I will come to that later. Now I want to know that. So we can, at this moment, we can print something on screen. So we can print some result on screen. Now, instead of taking these values as a fixed value, I want to take this from user. Okay. So what will be the way to take these values? So I will use another function, which is again predefined, and this one is declared in stdio.h. So here I want to take integer value, so percentile D, then I have to use ampersand of x. Why it's ampersand, I will come to that later. Okay, so this one is scanf percentile D. I want to take the value of x as well as y from user. Okay, so I will take it from keyboard, and finally the result will be printed. So here, if I run this program, I'm running this program here. So if I run this program, this is a blank screen. So I'm taking some input 15 for X, then I will press enter. Then I will enter another value 23. If I press enter, the result is 38. Okay. So using scanf function, we can take some input from console. So if you use scanf function, you can enter some value, you can take some value as input to the program from user. Okay. So this is the way how it works. So the value of X is 15 here, value of Y is 23, and the result is 38. So it will calculate sum and the result is 38. So this is the program. Now, if I run this program here, so initially the screen is blank. If you get a software, you have downloaded a software, when you are trying to run it, the screen is initially blank. Is it a good software? What do you feel? That you don't know, you have executed, you have not received any manual. So you have just installed the software. When you are running it, it is expecting for some input. Okay. Now, if it is expecting something as input, as a user, you don't have any idea about it, that what kind of data you have to enter. Then it's not an acceptable at the user end. So when I'm writing this program, I should add some messages. Okay. So what kind of message I shall add? So I will add one printf statement. So this printf statement is something like, this is a calculator to add two integer values. Okay, so it's a calculator to add two integer values. Now I will use some statement to guide the user so that user can enter some value. So enter an integer. Okay, so it will ask to enter some integer value. Then I will write, so it will take X as input from the user, then enter another integer. Okay, now if I run this program, then it is being printed. This is a calculator to add two integer values, enter an integer. Okay, now I am entering 14, enter another integer. So I will add 36, the result is 50. Okay, so when you are writing the program, when you are taking some input from the user, you should write some message for the user so that user can understand that what kind of, whether the program is executing properly, is it system, whether the system has hanged or it is expecting some input. If it is expecting some input from the user, what kind of input it will expecting. So you should mention it so that user can understand that what is happening in the background. Okay. Now, when I have executed this program, everything is being printed in single line. Okay. Now, I want to print it in different line. So there is a provision in printf at the end of this. If I enter \n, it indicates that it will enter a new line here. So if I use \n twice, it will print two new lines. Just let us test. So now this is a calculator to add two integer values. So one new line is here and another new line is here. So after this, now it will show you one message that enter an integer. Now I am entering 14, enter another integer. I'm entering 366. The result is 380. Okay. So when you are writing any program, please use some printf statement within the program so that it can be helpful for the users to understand what is happening in the background. And if it is asking for any input, then what kind of data the user should enter. Okay, so make a practice of it so that whenever you will write any program, try to add these things in your program. Okay, do you have any query at this moment?
No, sir.
Anyone?
No, sir.
No, sir. Okay, fine. Uh, okay, from the next day, uh, this is the very basic thing. So we have just tested that how to take some input from the user. Just only one type of input we have talked here, that is only integer values. And if we want to perform some calculation, then we can perform it and the result can be generated and it can be printed. So in the next class, we will start with different data types. Okay, so we'll start discussing from here. So we have different data types, and then we'll try to design or write something for simple calculation like factorial of a number and very basic things. Okay, and we'll try to understand some techniques of loops. Okay, conditional statement, branching. So many things are there. We'll continue one by one. Okay, so in the next class, we will try to understand what are the different data types and why we have to choose appropriate data type. So we'll come with some examples so that you can understand that for this type of data, we have to use this data type. Okay, and just before concluding it, I will try to mention only one thing here, that the importance of data type is, as we have discussed here. So on your in your system, you have only, I'm assuming that you have 4 GB of RAM. Okay, you have 4 GB of main memory. So this memory is being used by many processes as well as operating system. Okay, so many processes are running as well as operating system is running. So this amount of memory is being shared by many things, many processes in your system at this moment. So when we're writing a program, we'll try to reduce our memory consumption. Okay, so if one data can be fitted into a short type of data in 2 bytes, we should not use 4-byte memory allocation for that data. Okay. At this moment, you may think that I have sufficient memory, 4 GB of main memory. So if I use 2 bytes or 4 bytes, that may not be a problem. But think of a scenario that when in real life, when you are developing some application, like uh, just if I consider one example like Macout. In Macout, more than 1 lakh students are there who are active. So if 1 lakh students are there, then for 1 lakh student, so 1 lakh means, sorry, how many? Uh, so this is basically 1 lakh. So I'm storing students' information. So for one student, if 30 bytes of memory is needed, so how much memory is needed for keeping this information of 1 lakh student? So 30 multiplied by this one, so 10 to the power 5. This number of bytes are needed. So it's actually approximately this value is 3 MB. Okay. Now, if I can reduce, instead of using 30 bytes, if I can reduce this memory consumption for one student's information is 5 bytes, then if I can manage this data in 25 bytes for storing one student's information, then how much memory is needed? Instead of 3 MB, it will be just 2.5 MB. So therefore, an application like whatever kind of examples you are taking here, or this type of examples, you may think that this memory consumption is not too large. We can afford it, whether it's 2 byte or 4 byte. I have 4 GB of memory, so that's sufficient. So I don't bother about it. But actually, when you are developing any application, then you should keep this thing in mind, that appropriate data type needs to be selected so that memory consumption can be reduced. Because in real life, we are talking about huge amount of memory. Like if we think of State Bank, how many users' informations are stored in that system? It's more than 10 million. Okay. If we say only 1 million, so just for example, I'm thinking that 1 million users information is stored there. So 1 million for one customer's information, if it requires 50 bytes of data. Now, if I can reduce it to 40 bytes, then how much memory we can save? That's the main purpose. So from the very first day, be prepared that whenever you are declaring a variable, it should be, you should use proper data type. So it should be optimized. Okay. Okay. So today we have just talked about few things. Today we have just talked about few things. One is printf function, just beginning of discussion of printf function, scanf function, main function, and one data type only, that is integer data type. Okay. So from the next class, we'll start with some examples and we'll gradually we'll discuss the topics. Okay. Okay. If you do not have any doubt, we can end this session for today. So okay, bye.
So, attendance.
Okay, I will